Example number 2. A sociologist wants to discover whether the sexual activity of females between the ages of 15 and 19 years and the family structure are associated. She randomly selects 380 females between the ages of 15 and 19 years and asks each to disclose her family structure at age 14 and whether she has had sexual intercourse. The results are shown in this table down here. The data are based on information obtained from the National Center for Health Statistics. But we first want to compute the expected values of each cell under the assumption of independence. So in my chi-squared template here, I'm going to first put in all of this lovely data. So we have 64, 59, 44, 32, and 86, 41, 36, and 18. Underneath this expected tab, we have these expected values down here. So I'm going to, hopefully quickly enough, copy over these results, but just with some parent on the names of these. So using yes and no, so if we have both biological parents or adoptive parents, the expected counts were 78.55, and 71.45. For a single parent, this was 52.37, and 47.63. And for the parent and step-parent, this would be 41.89, and 38.11. And then the last one of non-parental guardian. And this will be 26.18 and 23.82. And then to verify that the requirements for performing a chi-square test of independence are satisfied, so we have those assumptions on here. So we want to verify that these requirements, whoopsie daisy, are satisfied. So first we want to know, do we have a simple random sample? We were told in here that we have it's a random selection. So yes, we have a simple random sample. We want to know if we have a large population. Well, we had here a total of, and I don't have that number directly in front of me anymore. We have a total of 380 observations. So if we took 20 times 380, that makes, let's see, 7,600. The number of teenage females between 15 and 19 years old is bound to be much greater than 7,600 in the United States by itself. So this assumption here is fine. And then the last one, which was that each of those expected counts needs to be at least 5. Everything here is at least 5. So all those expected counts are much greater than 5. So all those are good for this. So all 3 of these requirements are satisfied for the chi-squared test. This third one wants to compute the chi-squared test statistic. So here we have a degree of freedom of 3, right? We subtract 1 from the rows and 1 from the columns. So 1 times 3. So degree of freedom is 3. The chi-squared test statistic is equal to 10.36. And for this last one, we want to test whether the family structure and sexual activity of 15 to 19-year-old females are independent at the 5% level of significance. So let me very quickly move this up. At least attempt to move it up and not mess up the formatting. That'd be nice. That's a bit better. Okay, so we want to test whether the family structure and sexual activity of 15 to 19-year-old females are independent. Okay, so for this, we are using the null hypothesis that they are independent. So family structure and sexual activity are independent. For the alternative, we have that the family structure and sexual activity are dependent or associated or just plain out not independent. We have a p-value here of 0.0158. I'll put that up here so I have more room to write. 0.0158. Let me just fix this p. So that's the p-value. And now we can write this as a conclusion, and hopefully not mess up this formatting again. But as a conclusion, this should be at the 5% level of significance. At the 5% level of significance, we, in this case, our p-value is 0.0158, and that's compared to 5%, so that's much lower than 5%. This would be at the 5% level of significance. We have evidence to suggest that sexual activity and family structure for 15 to 19-year-old females are dependent. So at the 5% level of significance, we have evidence to suggest that sexual activity and family structure for 15 to 19-year-old females are dependent, according to our chi-square test.